Hi everyone, my name is Lamisa, and today I'm going to be answering a really interesting question, which is why is lightning hotter than the sun? Now, we all know the sun is extremely hot, but did we know that anything is hotter than that? Well, now we do, and I don't think any of you knew that, so I hope this is a really interesting question, and I hope you learned something new. Also, don't miss out that every Sunday we have a limited edition video where we have our two guests, Ikra and Afia, coming over to do a video with us. And they are the most funniest chat you'll ever meet. So stay tuned for that, like and subscribe for more videos. Let's start off with a joke. I thought I guess you guys might have thought we're going to move on to the first paragraph, but no, I like to start with a joke. Why does lightning strike at a tree before a person? It takes the path of leaf resistance. Okay, not funny enough. Don't worry, there's gonna be more. Starting with the real birthplace of lightning. Lightning is one of the most extreme natural phenomena on Earth. A single lightning bolt can reach temperatures of about 30,000 degrees Celsius, which is actually 5 times hotter than the surface of the sun. But the sun's surface is about 5,500 degrees Celsius, which is really hot compared to us on Earth, but lightning is even hotter, which also concludes and leads up to why some people die from lightning. I mean, you would die from the sun. But here's my question. Why is lightning? Why can we look at lightning without having to blink our eyes if it's that hot? Well, the sun is brighter than lightning, but lightning is hotter. So which one? Don't worry, because you will find out at the end of the video. And if you have any questions, don't forget to comment and ask down below in our posts that we do all the time. Any questions, you can just ask me and I will answer them for you. And if you still don't understand, I'll simplify it for you so you definitely understand. Carrying on, instant heat intensity, which is winds by lightning. And this happens because lightning is a sudden burst of electrical energy moving through air, which superheats it instantly, which also leads up to storm clouds as electrical factories. And lightning begins inside massive storm systems called cumul. Okay, maybe this might be a little bit hard, but it's pronounced cumulonimbus. And if you don't, let's slow it down a little. Cumulonimbus. Oh my Cumulonimbus. Cumulonimbus clouds. And if you don't know what that means, here it is. They act like natural electric factories because inside them violent air currents which push water droplets, ice crystals, and hail up and down at extreme speeds, and these collisions constantly transfer tiny electrical charges, slowly building up the huge imbalance of electricity inside the cloud. So here I have a diagram for you. It's a lightning heat diagram. And you can see here that we've got positive and negative symbol. Now the plus is the positive, the dash kind of hyphen, negative, whatever you want to call it, is, well, minus, whatever you want to call it, is negative. And the negative and the positive what rubs together like this when you rub your hands, and it also causes the friction, which causes the cloud to ground lightning. So as particles collide, lighter ice crystals usually gain a positive charge and rise upward, while heavier particles gain a negative charge and sink. This creates a system called charge separation, which is the splitting of positive and negative electricity into different regions. Over time, this turns the entire cloud into a gigantic electrical field. So, why air normally stops lightning? Air is normally an insulator, which is a material that blocks electricity from flowing. And this is because gas molecules are spaced too far apart for electrons to travel easily. So even though clouds are charged, nothing happens at first because the air acts like a a protective barrier. So when the air becomes broken, the electric field becomes extremely strong. It forces electrons to rip away from air molecules. And this process is called dielectric, let's say it together, dielectric breakdown, which is when an insulating material suddenly becomes conductive due to extreme electrical stress. Now, I know this was a lot, but don't worry, still don't understand? Don't forget to comment on our posts. I don't know if I said that at the start, but we have posts and I send posts all the time. So any questions you can just comment to me and you can comment, and if I'm not available, someone else around the world might know the answer and they can help you out. So don't worry. And at this moment, the air stops being a barrier and becomes a pathway for electricity to the formation of plasma channels. Once breakdown begins, I think I said breakdown, it's breakdown, begins, the air turns into plasma, a superheated state of matter where atoms lose electrons and become charged particles. Plasma is extremely hot, bright, and conductive. It is the same type of matter found in stars, meaning lighting briefly creates star-like conditions in Earth's sky. And I think we haven't done a joke for a while, so let me give you guys a joke. What do lightning bolts eat for breakfast? Huh? Huh? Chocolate cereal! That one was hilarious. Not funny enough? Well, I've got an even more funnier one waiting for you. But let's read some more. The invincible searching process. Before lightning becomes visible, the cloud sends out faint branching electrical paths called stepped leaders, which are invisible channels of electricity moving downward in small steps. These leaders explore the air, branching randomly, like glowing roots searching for the ground. Moving on, as the step leader gets closer to Earth, positive charges ride upward from tall objects like trees, buildings, and mountains. When they will not try because they just meet a complete electrical circuit form. And this connection is the trigger point for the main lighting discharge. And that was the answer to the ground response and connection. Which and this what we just read is meant to show the ground response and connection. So we're gonna look at the return stroke explosion, which is after connection, a massive surge of electrons rushes upward from the ground into the cloud. And this is called the return stroke. And it is the brightest and most powerful part of lightning because it can carry currents stronger than 30,000 amperes enough to instantly heat the air channel. So why it becomes hotter than the sun, which is our last and most wanting to know question. Well, the extreme temperature happens because the energy is released almost instantly into a very narrow channel of air. Channel of air. Unlike the sun, which produces heat through slow nuclear fusion, which is atoms fusing in its core. Lighting compresses enormous electrical energy into microsecond long bursts, creating the intense localized heating of around 2000 degrees Celsius. So now for your final joke. Well, here you go. How how did the no, what happens when a French chef gets struck by lightning? They become a monsieur. Funny, eh? Well, thank you, and please like and subscribe to my channel. I really hope you learned something new, and remember to contact at Learning with Stick. I really hope you learned a lot in this video. If there's nothing you If there's something you don't understand, you can always comment in the posts. And thank you so much for listening. I hope you had a great time learning today, and I hope to see you in the next episode. Bye.